Hello students, welcome to Science Tube. Today I'm going to show you how to derive the expression for kinetic energy. Okay, what is kinetic energy? We know the expression for kinetic energy is half mv square, where m is the mass, right, and v is the velocity. Clear? So how do we derive this equation? So for that, we should know that whatever work is done is stored in the form of energy, right? So initially, we need the expression for work done to derive the expression for kinetic energy, because this work done will be stored in the form of kinetic energy. So this is our first equation. W is equals to force into displacement. Okay, now suppose there's a body of mass m. Okay, there's a body of mass m moving with some velocity. Okay, we know that what is the formula for force? Mass into acceleration. All right, so this is my equation 2. Now let us find the expression for displacement. Now how do we find the expression for displacement? Students, do you remember the equations of motion? What was the equation of motion? One of the equation of motion was this: v square is equals to u square plus 2as, where s is the displacement, a is the acceleration, u is the initial velocity, and v is the final velocity. So suppose there's a body of mass m moving with starting from rest, so initial velocity is 0, and attains a velocity v after certain time, all right, and covers the displacement s. So from here, if you place the initial velocity 0, what do you get? V square is equals to 2as, correct? What do we need? We need s. So s is equals to v square by 2a. Now you place the value of s in your equation 1 and also the value of f in your equation 1. Okay, so what will you get? W is equals to f is mass into acceleration into displacement is v square by 2a. All right, a and a gets cancelled out, so we are left with mv square by 2, which we can write as half mv square. And as I told you, whatever work we do is stored in the form of kinetic energy. So what do we get? Kinetic energy is equals to half mv square. Is it clear? This is how we derive the expression for kinetic energy. And students, in the middle, I have told you that we have to suppose there's a body of mass m. All those statements you just need to write in the beginning, that suppose there's a body of mass m moving with starting from rest, attains a velocity v after a certain time, and covers the displacement s. All right, so all these initials you just have to write in the beginning, and then you have to derive it this way. Is it clear? Okay, thank you. Students, now let us derive the expression for potential energy. So how will we derive the expression for potential energy? We know that potential energy is denoted by symbol U, and it is equals to mgh. Now how do we derive this expression? Okay, initially we will start with work done. As I told you while deriving the expression for kinetic energy, that energy is nothing but work done. Work done is stored in the form of energy. So therefore we will start again our derivation with the expression of work done. All right, so we need F and we need S. So let us suppose there's a body of mass m. There's a body of mass equals to m, and the body moves to a height h. All right, it may come down by height h. It may cover, you can say in short that it covers a displacement h. It can go from bottom to up, or it can come down from top to bottom. All right, so a body of mass m covers the displacement h. So in this case, what will be the force? We know, since either it is going up or coming down, the force will be equals to m into g. All right, and displacement is equals to h. So if you place the value of force and displacement in this expression, what it becomes? F is mg and S is h. So what do we get? Work done is equals to mgh, and this work done is stored in the form of potential energy. So what do we write? Potential energy is equals to mgh. Is it clear, all of you? M is the mass, G is the acceleration due to gravity, and H is the height. Okay.